Okay, once we have created the mesh, now we have to give parameters, inlet parameters like flow data. Okay, we will need a hydrogram first that we will create with heck at HMS. Uh, this software is different than Iber, is another one, and we have to create a hydrogram like this one, okay, with a water flow here and time in seconds, okay, only a hydrogram, like could be this one, okay, with a peak, with everything that has an hydrogram. The only thing is that heck HMAs is working with minutes, and Iber needs to work with seconds. So we will have to transform the minutes into seconds. Okay, sorry. So we will need to transform it to translate the minutes into seconds. It doesn't it it doesn't matter if it is 300, 600. It doesn't matter. The only thing is that it has seconds. So okay, we go back to Iber, and first for introducing the data, we have to go to data. We have to go to hydrodynamics and boundary conditions, because it's boundary conditions what we are going to create and to introduce into our data. We click, and we have here a window where we can select between a total discard, where first of all we can select into an inlet and an outlet. For initial conditions of input hydrogram, we need 2D inlet because it's two-dimensional and inlet. Okay, here we can write into a specific discharge, specific water elevation. Is the water elevation what we know, maybe because of evidences that we have here in the river, but we don't know any water flow, or stepped discharge. Normally we will use total discard. Here we can go into supercritical with time, flow and velocity, or critical subcritical with flow and time. Here we will introduce our data from Excel, from the hydrogram. Only we have to copy. We have to copy, Control C, copy, click here, and Control V, paste. Okay, copy and paste. Once we have the data here inside, we will go to assign, and we have to go to the first line we created in the polygon of the river, because this will be the place of the inlet of the water flow. Okay, this is very important. We have this line here, this perpendicular line to the river. As I said in the first tutorial, we need to create the polygon of the river, but we need to start with a with a line perpendicular to the flow, okay? That this will be the place where the water flow comes into the river, okay? So we will go to this, we will place the flow here, we will select the first line, and we press escape in our keyboard or finish. Once we do this, nothing changes here visually, but we have a water flow here, a hydrogram. This will be the first item for our analysis, for our fluid analysis. Okay. Later, what we have to do? Okay, to run a water flow here in the river, we need to create an outlet to say to the program where the water flow comes and where the water flow goes. We will create the outlet regardless of the fluid that we think that will be here or here. We have to create the outlet where the outflow of the river is. We don't create here because the water, we want to go the water into the city. No, 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 no. We have to create it into the outflow of the river. So we go to the outlet, and we have here supercritical conditions or subcritical conditions. Here in subcritical we have a lot of type of input of the data. We have a var, a given level, a rating curve Q. Var is the most common for everything. When we don't know any of these parameters, a given level, a rating curve, or a rating Q, we will select var, because with this we make sure that we have a var height of 0. That means that the water comes from here and goes out until it is 0 in the water level. Okay, in the water level is 0, and we have an outflow of 0 meters. That is until the reaching the river if it was dry. So if we have a given level, maybe for when we have the level of the sea of an ocean or something, when the river goes to an ocean, we can give a given level like this one. We place like 0 meters or 10 meters if we have a lake or something, and we go to a given level. Rating curve, if we know our rating curve or curve of the outlet of the river, we can create a rating curve and a rating curve Q, but we will use where, there. We will make sure that this level is in 0, okay, because if not, maybe we have more water here coming without finishing the flood. So we make sure that it's a 0 level, and we go to assign. We zoom into the outflow of the river, that will be this line. We select it, and later we press escape again, and we close. So that's it. That's it for this step. This step is the only step, is the only finished step for knowing how to create boundary conditions, and to say to the program, to the software, that we have some flow, some water flow inside our program, and our inside our parameters of hydrodynamics. And that's it for this step.